right, can you guys hear me?
You're muted. Where are you talking? You're muted on everything.
Duck, everybody duck. Darn it, I'm recording.
I don't think it matters.
I don't think it matters.
Yeah, if you unmute yourself somewhere.
Okay, can you guys see and hear me?
No.
No? I'm frozen?
Some people are. No,
You can hear me. We're doing it.
No.
All right. If things get really bad, somebody unmute and tell me what's going on. Or wave crazy at Mrs. Greenhouse. All right, here we go. So guys, we have been solving systems. We're still going to be solving systems. We now know 3 different ways: graphing, substitution, elimination. The problem is now they're going to give you word problems. And I know you guys hate word problems, but I'm telling you, these ones really aren't that bad. They're very repetitive. They kind of the same thing keeps happening and happening. All right, so now they're going to give you a word problem where you're going to have to write your own system. You're going to have to write 2 separate equations and then solve them. Normally, you guys solve them by elimination because that normally ends up being everybody's favorite. Okay, so here we go. We're doing system word problems. So I'm probably not going to solve them. I'm probably just going to write them because you should be able to solve any system at this point. All right, here we go. So here are some steps. Number 1, you want to read the problem very carefully. Number 2, very, very important. You have to ask yourself, what does the problem ask you to find? You got to figure out what you're trying to solve for. Once you know that, then you're going to pick 2 variables to represent the information that you are trying to find, because we don't know what it is yet. And then you're going to write a system of 2 equations using those variables, and you're going to solve. All right, so we're going to start with a pretty basic one. Ms. Greenhouse, how are they looking over there, okay?
They're good. Yep.
All right, so number 1 is probably as easy and as basic as these problems are going to get. It says, Michelle is thinking of 2 numbers. The sum of those 2 numbers is 12. The difference of those same 2 numbers is -4. Write and solve a system of equations to find the 2 numbers. All right, so we've read the problem. Now we have to figure out, what are they asking us to find? They are asking us to find the 2 numbers. We do not know what these 2 numbers are. So in math, when we don't know something, we use a variable to represent it until we do. So we're going to use x and y. I'm going to let x equal the first number that I do not know, and I'm going to let y equal the second number that I do not know. Okay, so now we're going to use x and y to write 2 separate equations. So they should have told us 2 separate pieces of information that we could use to write 2 separate equations. And they did. First, they told us that the sum of these 2 numbers is 12. So now we know that these 2 numbers, x and y, they have to add up to 12. So we can write that as a mathematical equation. X plus y better equal 12, right? The 2 numbers that we don't know better add up to 12. All right, then they told us that the difference of those same 2 numbers is -4, right? So now I know that I better, difference just a fancy word for subtraction. Now I know these 2 numbers have to subtract to -4. So I can write that as a mathematical equation just like that. And now I've written my own 2 variable, 2 equation system. And now it's your job to solve it. So hopefully, solving's the easy part, right? This is set up beautifully for elimination. So you know what? I'll solve this one really fast. If I add them together right now, my y's will cancel. I'll get 2 x's. The y's cancel, equals 8. Divide by 2. And then you find out that x is equal to 4. So now I know the first number, x, is 4. So I always come back here and I label what I put my answers to each label. So now if x is 4, what's y? What's the second number? Well, guys, remember, they had to add up to 12. So if x is 4, 4 plus who gets you to 12? Y has to be 8 then. You can get the second answer just by plugging into one of the equations that you wrote. Is everybody okay with that? So on quizzes tonight, on your homework, you only have to solve 2 of the systems. The other ones, you just have to write the system. But on the ones where you have to solve, they're going to ask you to write your answer as an ordered pair. But I don't know what variables you used, and I don't know, maybe you let x be the second number and y be the first number. So when you go to write your answer on quizzes, when you write the ordered pair, the order won't matter. If you write 4, 8 or 8, 4, it's okay. It's going to accept both of them. I also let you type it without parentheses. So if you didn't even put the parentheses, it's still going to mark you correct, okay? Ms. Greenhouse, look for them. Guys, can I get a thumbs up that you feel okay about at home? Everybody's okay? We're following along? Guys, we're okay here? Okay. All right, let's try number 2. I'm going to try and move it up. And then we'll get the next 2 on the next week. Okay. All right, here we go. So look at number 2. The Nautical Star Theater Company sold a total of 555 tickets to this year's school play. Student tickets cost $4 each, and adult tickets cost $7 each. If the total receipts were $2,895, how many student tickets and how many adult tickets must have been sold? Okay, so we've read the problem. Now you gotta figure out, what are they asking you to find? They are asking us to find how many student tickets and how many adult tickets were sold. So we have to establish variables to represent that piece of information. So normally I would use like S for student tickets and A for adult tickets, but I'm pretty sure your homework always uses X and Y, so I'm just gonna stick with X and Y. So I'm gonna let X equal the number of student tickets sold, and I'm gonna let Y equal the number of adult tickets sold. Okay, so now I have to write 2 equations using X and Y. So first, we're gonna write an equation that just talks about the amount of tickets sold, and then we're gonna write an equation that brings the money involved in, okay? Well, think about it. If this many student tickets were sold, and if this many adult tickets were sold, they have to add up to some total amount of tickets. How many tickets did they sell? They sold a total of 555 tickets. So I know this and that have to add up to 555. So how do I write that as a mathematical equation? I say X, the number of student tickets, plus Y, the number of adult tickets. It better equal the 555 tickets they sold. Okay, that's the easier equation. Now, the second equation, the other information they talk about is about the money, all right? Each student ticket costs $4, and each adult ticket costs $7, and they made a total of $28.95. All right, so guys, this is how many student tickets were sold. Each one of those tickets sold for $4 a piece. So that's $4 per X. That's $4 per student ticket. So how do I show $4 per X? 4 times X. Plus, if this is how many adult tickets got sold, each adult ticket costs $7. So that's $7 per Y, or $7 per adult ticket. So how do I show $7 per Y? 7 times Y. And then it has to equal what was the total amount of money they made off of these sales? $2,895. And now you've written 2 separate equations using those 2 variables. So if you notice, the first one's usually the easier of the 2 equations, and then you got to bring all that money that is involved in. So guys, if I was going to solve this, I would either times the top equation by a -4, so my x's could cancel, or I would times the top equation by a -7, so my y's cancel. And then you could use your elimination and solve for x or y. Again, I shouldn't have to solve it. You should know how to solve it once you're given the system. But if you want to solve it later, the answer was 330 student tickets and 225 adult tickets got sold. If you wanted to check your solving later. All right, everybody okay? All right, let's try number 3. Everybody looks good still on the meet?
Yep.
Okay, look at number 3. I feel like whenever we do system word problems, the coins are very popular. No, we're not going. We're not going.
You can't be freaking kidding me.
We're doomed. Today is just doomed.
No, I don't. There's no other words. Why is no one else coming out? Are we
I'm not going. I'm not going.
What if he's trying to drill?
What if it's not a drill? I don't know.
That's weird.
Well, are we going?
I mean, we have 2 children.
Legally, I think we have to.
I know.
All right, guys, we'll be right back. We have a fire drill.
This is underwear.
Yeah, don't do anything without us.
I know.
Like, I don't even understand what the hell is happening.
I'm leaving the video back.
Well,
Oh my god, you're recording.
I don't know.
Is this necessary?
It's still going.
Thank you all for your cooperation. You may now enter the building at this time.
And I have no idea, because I can't see them, so I have to keep asking you if they're okay.
Oh, yeah, no,
Can
they're
you
fine.
believe this? Like, what? Like, I'm just not meant to teach you system word problems, I think.
That was fun.
That was good, that was worth it. Are they there? Everybody still there?
Everybody's still there.
We're back!
Hi, everybody.
My God, you poor people that have to watch this video. I am so sorry. All right, here we go. So look at number 3. What I started to say is that when you're doing a system word problem, the coin problems are very popular system word problems. So you're almost guaranteed to always get some type of coin problem. All right, here we go. Bill has a collection of 35 coins that contains nickels and dimes. Find the number of nickels and dimes if the total face value of the coins is $2.55. All right, first of all, what have we just been asked to find? We have been asked to find the number of nickels and the number of dimes. So I'm going to let X equal the number of nickels, and I'm going to let Y equal the number of dimes. All right, now we have to write 2 separate equations using X and Y. So we have to find 2 separate pieces of information about these coins. Well, one piece of information is the total number of coins, so we're going to write an equation about that. The second piece of information they told us is about the value of those coins. So then we'll write an equation about the value. All right, so let's do the total coins first. Guys, if this is the number of nickels you have, and this is the number of dimes you have, they have to add up to the 35 coins. So how do we represent that mathematically? We say X, the number of nickels, plus Y, the number of dimes, has to equal the 35 coins that we have, right? Okay, now we have to write the money equation. Now we have to bring the value of these coins in. And guys, here's the problem. Most of the time in math, the numbers that you use are written somewhere in the problem. But in a coin problem, they just expect you guys to know what a nickel is worth and what a dime is worth. So they're not going to write those numbers in the problem for you to use. You just have to know it. All right, so guys, let's bring the money in. If this is the number of nickels, then each one of those nickels is worth 5 cents. So how do I show that I have 5 cents per nickel? 5 cents per X. That would be 5 cents times X. So 5 cents is 0.05 times X. A lot of students end up putting 0.5, and that's 50 cents. 0.05 is 5 cents. All right, plus, now this is the number of dimes. If I have dimes, then each dime is worth 10 cents. So that's 10 cents per dime, or 10 cents per Y. How do I show 10 cents per Y? That's 0.10 times Y. And then that has to equal, what's the total amount of money that we are playing with? $2.55. Okay? And then what I would do to solve this, I like working with 0.10 better than 0.05. So I would times the whole top by negative 0.10, and then I would get my y's to cancel out. You just got to work with decimals. Just be careful on your calculator, okay? If you wanted to solve this later, you find out that you have 19 nickels and 16 dimes if you want to solve it later to see if you solved it correctly. Okay? All right, I'm going to do 4 and 5 hopefully before the bell cuts me off.
They're all good.
You're all good still? All right, hang in there, guys. You're doing good. Like speed math. Okay, look at this one. A farmer has sheep and ducks. If there are a total of 36 animals and 96 legs, how many sheep and how many ducks does the farmer have? Okay, so we've just been asked to find how many sheep and how many ducks. So we're going to let X equal the number of sheep that this farmer has, and we're going to let Y equal the number of ducks. Okay, so now we have to write two separate equations. So they should have talked about two separate pieces of information. They talked about the number of animals, so we'll write an equation about that, and they talked about the number of legs, and then we'll write an equation about that. All right, so guys, if I have this many sheep and this many ducks, and I have this many total animals, that means they have to add up to 36 animals. So how do I write that mathematically? I say X, the number of sheep, plus Y, the number of ducks, that are equal the 36 total animals. All right, now we got to bring the legs in, They say there are 96 legs involved. Well, guys, how many legs does each sheep have? Each sheep has 4 legs. So they're going to bring 4 legs per sheep to the table. So if this is the number of sheep, I have 4 legs per X. So that would be 4X. Plus, if this is the number of ducks, then I'm going to bring how many legs does a duck have? Ducks have 2, right? So they bring 2 legs per duck to the table. So that's going to be 2 legs per duck, which is 2 times Y. And then that better add up to how many total legs they tell us we had? 96 legs. And then you would solve it. I would either times the top by -4 to get my X's to cancel, or I would times the top by -2 and get my Y's to cancel. If you want to solve this later, you find out that there are 12 sheep and 24 ducks, if you want to solve it later to make sure you're okay. Okay, I can do this. We got a couple minutes left. We're going to try the last one. All right, it says, Tom went grocery shopping last week, and he bought 7 oranges and 5 apples for a total of $19.90. This week, he bought 3 oranges and 6 apples for a total of $16.05. Write and solve a system of equations to find the cost of each orange and each apple. Guys, normally the problem will tell you the cost, and you have to find the number of oranges or the number of apples. This time they told us the number, but they didn't tell us the cost. So it's a little bit backwards, but we can still set it up the same way. All right, so we are being asked to find the cost of each orange and apple. So let's let X equal the cost of each orange. And let's let Y equal the cost of each apple. Okay, now we have to write 2 separate equations, right? So we're going to write the first equation based off what they told us about last week, and we're going to write the second equation based off what they told us about this week. So let's go to last week. Last week, he bought 7 oranges and 5 apples, and it cost $19.90. I'm going to finish this problem. If you guys can stay, great. If you can't, you can't. All right? So guys, if he bought 7 oranges, you would take the number of oranges and times it with the cost. So 7 times the cost of each orange is 7X. Plus, you have to go and understand, 5 apples, right? You would take the number of apples and you would times it with the cost per apple, which is Y. So that would be 5Y. And it equals how much total money did he spend on these apples and oranges last week? $19.90. Okay? The second equation. Now we're going to talk about this week. This week, he bought 3 oranges, so that would be 3 per X. That would be 3 times X. Plus, he bought 6 apples. So you would take the number of apples and times it by the cost, 6Y. And then that would equal, how much money did he spend this week? $16.05. And then you could either eliminate X or eliminate Y. I would get 21 and -21, or I would get 30 and -30, and I would eliminate X or Y. If you are solving this, you find out that I believe it's $1.45 per orange, and then $1.95 per apple, or vice versa. I don't know which one was which. No, that's right. Okay? I am very sorry that was rushed, but guys, this has been one hell of a day with the internet not working at all and then the fire drill. Okay? Can they get a thumbs up that they feel okay? Are they all right over there, Ms. Greenhouse? Okay, guys, thank you so much. I am sorry for this being so crazy. You have an assignment on quizzes that is due tomorrow on these word problems. As always, reach out to us if you need us. Have a wonderful day.
Bye.
Bye.
Bye, Marty.
Bye, guys.
Have a nice day.
You too.
Have a good day.
You too.